All right, sections 5.1 and 5.2. A few preliminaries here. First, what is a z-score? All right. Well, assuming that x stands for the data value, which it pretty much always does, then z-score is x minus the mean divided by the standard deviation. Or if you're dealing with a sample, it's the same thing. It's still x minus the mean divided by the standard deviation, but the mean and the standard deviation have different symbols. All right, so that's the formula for it. But what does it tell us? Well, there's a couple things, two different things. One, the z-score is a count of the number of standard deviations, SD, there are between the mean and the data value. All right. Also, the z-score converts a value in any normal distribution to a value in a standard normal distribution. In other words, if our data value here, x, is a value in any normal distribution at all, then what comes out of it, z, is a value in a standard normal distribution. A value in a standard normal distribution is also always a count of the number of standard deviations there are between the mean and the data value. Okay, if you don't have your calculator with you, please pause the video, go get your TI-83 or TI-84 calculator, and come back. All right. Now, find the arrow keys on your calculator. Just below the left-hand arrow, find the VARS key. Notice that the second function on the VARS key is DISTR, stands for distributions. Now, clear your calculator. Select the following keys. Second, DISTR. Notice that option 2 on your screen is normal CDF. All right, this is the built-in calculator function for finding normal distribution probabilities. You can select it either by selecting 2 on the keypad or by highlighting it using the down arrow and then hit enter. If you have a TI-83 or an older TI-84, when you select it when you select normal CDF, you'll see the following. So on the screen it says normal CDF open parenthesis. If you have one of the newer TI-84s, it will actually prompt you, ask you for the lower limit L. Okay, the inputs, I'll get back to what that means in a minute. The inputs to the normal CDF function are lower limit, upper limit, mean, standard deviation. Sometimes you don't need the last two. We'll get to that. To find a probability with one of the older calculators, just select normal CDF and then enter these 4 values and then close parenthesis, enter. If you have one of the newer TI-84s, after you select normal CDF, you will be prompted for the values one at a time. After the values are entered, select enter once to paste the values. The calculator says paste. What it means is it's going to take the values and put them into the normal CDF function, and then hit enter a second time to actually do the calculation. All right. So let's talk about the graph of a normal distribution. A normal distribution is a bell curve. Actually, it's like the definition of a bell curve, really. The perfect bell curve is a normal distribution. Okay, the mean is in the middle. It goes forever down. It goes from minus infinity all the way up to plus infinity. Okay. Another property of it, the main thing that we're going to use it for, let's say we've got a couple of numbers. Let's say like this is x1 and this is x2. Okay? Well, what happens then if you want to know the probability that your randomly selected value x here is between x1 and x2, well, it turns out to equal this area here. All right? So you understand, so that's kind of the thing, that's the cool thing, if you will, about a normal distribution is the area between the boundaries here, between the edges of x1 and x2 is also the probability of falling between x1 and x2. Sometimes the questions will ask you for the area or talk about the area. Sometimes they will ask for the probability. Either way, it's the same thing, really. All right. Now let's move on in to some questions and see how we use what we've talked about so far to find some probabilities. Finding area. In exercises 25 through 38, find the indicated area under the standard normal curve. If convenient, use technology to find the area. All right, let's talk for a second here. Standard normal curve. All that means is it's a normal distribution where the mean equals 0 and the standard deviation equals 1. That's exactly what standard normal means, and that's all it means. All right, so let's find the area to the left of z equals 0.08. First off, remember area is the probability, so area to the left of that is the same thing as a probability that z is less than 0.08. Now another thing, I didn't really mention this, I probably should have. The normal distribution goes forever. It goes all the way down to minus infinity, all the way up to infinity. You know, those are, right, it just goes on forever in both directions. Well, since we want, this question is to the left of 0.08 or less than, there's no lower limit, right? I mean, if you're going to put one in, you could kind of say minus infinity. I mean, it goes down forever. So anything less than 0.08 is what we're looking for. All right, so let's draw a picture here. We'll just draw a smaller one. So there's our x-axis. There's our graph. Now, because this is standard normal, the mean is 0. So 0.08 is a little bit bigger than 0, so we'll just put it in there. So the area to the left of 0.08 would be this stuff right here, right? Heading all the way down to minus infinity. Okay. Now now we're going to do this on our calculator. Normal CDF. So I'm going to select the normal CDF just like we did before with the open parenthesis. Now, remember what you need to put in is lower limit, upper limit, mean, standard deviation. Well, in this case, there is no lower limit, okay? And there's no way to put in minus infinity. What you do is you put in a really big negative number. Do something like negative 99,999. Okay? The upper limit is just the 0.08. You remember a moment ago, sometimes I said you only need 2 values? Well, this is the case. When it's standard normal, when the mean is 0 and the standard deviation is 1, you can just do the closed parenthesis. If you leave these two out, if you leave the mean and the standard deviation out, the calculator will assume that they are 0 and 1. All right? So oh, by the way, also, the negative sign here, you need to use the minus symbol that's next to the decimal point in the bottom row of your calculator. If you use the subtraction symbol, it'll give you an error. All right, so normal CDF, negative 99,999, comma. The comma is just above the 7, by the way. 0.08, and then this time we can close parenthesis because it's standard normal and hit enter. And we get the probability. Now it gives us the probability of 0.5319. I put it to 4 decimal places because that's what the questions usually are for probability. All right. So if you go back over to your picture, the 0.08 was a little bit bigger than 0, and 0's in the middle, right? The probability of being less than 0 would have been half, and 0.08's a little bit bigger than that, and we get a little bit bigger than a half, right? 0.5319. All right, so let's do this next one. To the right of minus 3.16. So let's draw another picture. All right. It's still standard normal, so 0's in the middle. This time we'll put minus 3.16 down here. It says to the right of that, so that would be like this. So again, remember, so this says ask for the area, but this is the same thing as the probability that x is greater than minus 3.16. And again, see, there's no upper limit, right? I mean, if you wanted to put one in, I mean, you could kind of say infinity like this, but it's a similar situation to what we had for the first one. So what we're going to do here is normal CDF. This time we know the lower limit is minus 3.16. There's no upper limit, right? So I'm going to use positive 99,999. And again, we're still in this standard normal situation, so I can just close the parenthesis and hit enter. So normal CDF, negative 3.16, 99,999, close parenthesis, enter. I get 0.9992. All right, so now let's try another one. You know what? we're not gonna do 37 at this point. If you want to try that on your own, it's in the book. Let's look at number 36. Find the probability of being between z equals minus 2.33 and positive 2.33. Again, you'll notice here, since it says z, that means we're standard normal, right? So the mean is still 0. The standard deviation is still 1. So if we draw our picture, there's our bell curve. 0 is the mean. So minus 2.33 would be somewhere down here. 2.33 would be in here. Now they're asking us for the area between those, so that's like that. But again, remember that's the same thing as the probability of being between those, right? So we'll just do our normal CDF. Now this time we have both a lower limit, right, and an upper limit. So minus 2.33 up to 2.33. Again, we're standard normal, so we don't need to put in the mean or the standard deviation. So let's see what we get. So DISTR, normal CDF, negative 2.33 comma 2.33, close parenthesis, enter, and I get 0.9802. So the probability of being between minus 2.33 and 2.33 is 0.9802, and it's also the probability on that curve. Now, let's look at this one. ACT English scores. In a recent year, the ACT scores for the English portion of the test were normally distributed with a mean of 20.6 and a standard deviation of 6.3. Part A. Find the probability the student's ACT score is less than 15. Okay, so this time it words it in terms of probability, right? But again, it's the same thing as the area. So let's draw the picture. All right, this time the mean is 20.6, so that's in the middle. We want less than 15, so that would be like something like down here, right? It's a less than, so there's no lower limit, right? So that's normal CDF. There's no lower limit, so I'm going to use minus 99,999 for the lower. 15 is the upper. Now this time we're not standard normal, right? We have a mean of 20.6 and a standard deviation of 6.3. So you have to remember to put those in there when it's not standard normal. Otherwise it's just what we've just done before. So second DISTR, normal CDF, negative 99,999, comma 15, comma 20.6, comma 6.3, close parenthesis, and we get 0.1870. So almost 19% chance that a randomly selected student score will be less than 15. All right, B. Find the probability that the student score is between 18 and 35. All right, so let's draw our picture again. We're still in this case where the mean is 20.6. All right, so we're going to have to scroll this down a little bit here. There we go. So we're still in a situation where the mean is 20.6, and we want between 18 and 25. So let's say 18, 25, right? We want it, it's that area. It's also that probability, right? Probability between 18 and 25. Normal CDF. All right, this time we have a lower and an upper, right? Here's the lower, here's the upper. So from 18 to 20, probability being from 18 to 25, when the mean is 20.6 and the standard deviation is 6.3. All right, well, let's kick that into the calculator, see what it says. So second DISTR, normal CDF, 18, comma 25, comma 20.6, comma 6.3, close parenthesis, enter. 0.4176. All right, so that the probability is a little bit less than 42% on that one. That is it for this video.